Okay, 1977 AB3. We have these two functions, or we have the function f of x equals e to the x over 2, which looks something like that. And then we want to find the area bounded by the line y equals e and the graph of f and the y-axis. So you have to be really careful with this one. We're not looking for something below e to the x over 2. We're looking for something in between that line and the line y equals e and the y-axis. So we're actually looking for this particular area instead of looking for something below the line e to the x over 2. We do need to find the points of intersection where e to the x over 2 is equal to e, and you can see that when e to the x over 2 is equal to e to the 1, then x over 2 must equal 1, and so x is equal to 2. So we want the integral from 0 to 2 of e minus e to the x over 2. And I'm going to split these up again as I did in the last problem. And I have e, since e is a constant, integral 0 to 2 dx minus the integral from 0 to 2 of e to the x over 2 dx. On the second one, I'm going to do a u substitution. U is x over 2, du is 1/2 dx, and 2 du is equal to dx. I'm going to swap out my limits of integration. So u of 2 is equal to 1, and u of 0 is equal to 0. So now I have e times the integral from 0 to 2 dx minus 2 times the integral from 0 to 1 of e to the u du, and I'm ready to anti-differentiate. So I get e times x from 0 to 2 minus 2 times e to the u from 0 to 1, and that is 2e minus 2 times the quantity e minus 1. So that's 2e minus 2e plus 2, which is just 2. Alright, so we're ready to go on to part B, and that is to find the volume of the solid generated by revolving R about the x-axis. And I'll scroll down for that. And so here we're looking to revolve that area around the x-axis. We're going to use washers again. We'd have something that looks like that. And again, this is pi capital R squared minus pi little r squared. And so V, volume, is equal to e squared. Here, the outer radius is e, so pi capital R is e, so we have pi capital R squared minus pi little r squared. And that second piece would be e to the x over 2 squared with the dx. And when I simplify that, the e to the x over 2 squared is just going to give me e to the x. And so I end up with pi times the integral from 0 to 2 of e squared minus e to the x. And I don't need a u substitution for this, so I'll directly integrate. The antiderivative of v to the second is e to the second x. The antiderivative of v to the x is e to the x, and so we get e to the second x minus e to the x from 0 to 2, all times pi. So I set up the two expressions, and I'm going to get e to the x times 2, so that's 2 e to the second minus e to the second. Then the first term evaluated at 0 is 0. The second term evaluated at 0 is 1. And I end up with pi times e to the second plus 1. And that's the answer to part B, and we're done with both parts there. Alright, we'll go on to the next problem.